Okay, so good morning, everyone. Today we will start a new chapter in our Cambridge AS level mathematics course, and the chapter is the sixth chapter of your textbook, and the chapter's name is series. Okay, so this is the sixth chapter of your textbook. Okay, so series. Okay, so this uh, this series part actually contributes a very major topic in mathematics, and many mathematicians have great contribution in this area, especially if you and all of the you must have heard about this name of S. Ramanujan. Okay, S. Ramanujan. He was an Indian mathematician, and his major contribution in this domain of series. Okay, he had proved some of the very groundbreaking theorems in this series domain. Okay. So, if you will ask me for some example of series, then simple series can look like this. Right? This is a simple series. And a series comes in two categories. Either it can be a finite series or it can be an infinite series. Okay. So this right here is an example of infinite series because these dots it actually tells us that uh, the the same pattern will continue till infinity. Okay. But finite series also exist, and they are very easy because if we have finite number of terms, then you can always find the sum. Okay, but if you have finite number of terms, then it become little bit different. The entire studies has a different axiom, and it is an entirely different game. Okay, so now we will see our first topic is binomial. Is about binomial. Is about binomial expansion. Okay, so it is about binomial expansion. Let me see. Yes. Okay, so it is about binomial expansion. Okay, so you should know that this by actually it means two. Okay, in mathematics or in general literature, the root meaning of this by word is two. Okay, so binomial expansion means what? Really expanding a series where the terms there we will be having two terms. So a general binomial expansion will be of this particular expression right here. So we have two terms, this A and B. Okay. So these are the two terms. That's why when we will expand it, it will be known as binomial expansion because we are expanding two terms. Okay. Now see, from your earlier studies, you are not very much new to this topic, and but what you were not dealing with this n right here. Okay. You are dealing with some sort of powers. Okay. So I will show you that you are studying like this a plus b raised to the power 0. If I substitute 0 in place of n, then it will become 1, right? Okay. Okay, so it is nothing but simply 1. But when I proceed with the same pattern, if I increase the power as 1, then it will be a plus b simply. Okay. And our main focus should be on the coefficient that is present in front of this variable set b. Okay, so right now the coefficients are okay. So here let me write it in blue. Okay, so if I continue with the same pattern, these are nothing but mathematical identities. For example, if it comes to a plus b square, all of you know that is nothing but a square plus 2ab plus b square, right? Similarly, when it comes to a plus b cube, we have a cube plus 3a square b plus 3ab square plus b cube, right? So again, let me highlight this coefficient by this blue color. It will be 1. Again, we have 1, we have 3, and we have 1. Okay. Now see, uh, if we will look carefully, then we are getting a pattern here, right? So if I write the coefficient on the right side, see one I have written, then I will write this 1 and 1 like this. Okay. Then if I add these two terms here, if I add this 2 1, then I will get a 2 here. And if I write this 1 and 1 on the right and left hand side, then I will get this pattern here, right? This 1, 2 and 1. So I got this pattern. And if I add these numbers here, in this 1 and this 2, if I will add it, I will get 3 here. Again, I will add 2 and 1, I will get 3 here. And I'm writing this 1, I'm writing this 1 and 1 again. Okay, so I have got these coefficients, right? This 1, 3, 3, 1. Okay, so this is a very standard pattern in mathematics, and this pattern is known as Pascal's triangle. Okay, so this pattern in mathematics is known as Pascal triangle. Okay, so how you construct Pascal's triangle? Let me show you one more time. Okay, so in order to construct Pascal triangle, what we will do? We will just simply start by 1. Then I will write 1 and 1 again. And now I will add these two numbers. I will add these two numbers. I will write the summation here. And I will just copy this 1 and 1 on the outer side of our triangle. Okay. Then again, I will add these two numbers. The sum will be 3. 3 will come here. And this again, 1 and 1 will be like this. So if we continue again, so then it will be 4. 3 plus 3, it will be 6. 3 plus 1, it will be 4. 1 will, again, we will write it. Okay, so this one, if we try to write it, it will be for a plus b raised to the power 0. This first line. The second will be, so these numbers are nothing but the coefficients. Okay, you can see that these numbers are nothing but the coefficients when I try to expand this binomial with this particular power. For example, if we try to expand a plus b with the power 2, then if we want to know the coefficients, then these coefficients are nothing but this 1, 2, 1. Okay, and they are nothing but the third row of our Pascal's triangle. Okay, so they are nothing but the third row of Pascal's triangle. So till this four formulas, the coefficient of this four mathematical identity, most of the students pretty much know this because a plus b raised to the power 3 is a very common identity used very often in mathematics. But this a plus b raised to the power 4 is not that much long. Okay? So if someone asks you that write the formula of a plus b raised to the power 4, so what you will do? You will just draw this triangle quickly. It doesn't take that much time. And now, what is our step? Our step is to see. First, let's observe the identity a plus b whole raised to the power 3. Okay, so if you will observe that identity carefully, then you will notice the pattern. Okay, so the pattern is something like this. This is nothing but a plus b whole raised to the power 3. Okay, so I will pick any one particular expression from this binomial term. I will, for example, I will pick the a. Okay. And I will raise it to the highest power peak. Okay, so the highest power that you can have in this particular expression is 3. Okay, so I will raise it to the highest power. Okay? And the coefficient I will choose from this row. Okay, so the first coefficient I have picked is 1. Okay, so I have used this coefficient and I have raised it to the highest power. Now I will apply the addition sign because this addition sign comes here. Okay, then I will put the second coefficient here. This 3 will come here. Now in the second term, what I will do, I will decrease this power. I will decrease the power of a by 1. Okay, so I will decrease the power of a by 1, so it will become a square. And earlier, if you can notice that I can also write b raised to the power 0 here. Okay, the second coefficient b would also have been written in form of b raised to the power 0. So what I will do, I will increase the power of b by 1. Okay, so earlier the power was 0. Now it will get the power 1. Okay, and I will proceed with the same steps. I will pick the another coefficient. The next coefficient is 3. Then what I will do, I will reduce the power of a by 1 and I will increase the power of b by 1. Okay, so I will reduce. So what I am doing, I am reducing the power of a by 1. So it is becoming minus 1. And I'm increasing the power of b by 1. Okay, so it is getting plus 1. So a cube, then a square, then now we will be having only a, but the power of b will be b square. Okay, and for the last term, my coefficient will be this one, and so one will be written here, and here we should have written one. Okay, so it is nothing but one. And now the power of a, because now it will again reduced by one. So when I subtract one from its power, it will become zero, and this power of b will increase by one. So it will become b cube. Okay. So you can see that this expression that we have written here is nothing but our identity a plus b, the whole cube. Okay, this is nothing but the same identity a plus b, the whole cube. Okay, so but see, we do not use this method because everyone remember this identity. But if you want to, if you apply the same method and if you want to actually write the formula for a plus b raised to the power 4, so what you will do, so let me erase it here. Okay, let me raise it here so that I can pick the coefficients. So I will apply the same method in order to find the identity of a plus b whole raised to the power 4, and it is the same methodology, picking the coefficients and increasing and decreasing the powers of those two variables. Okay, so first I will pick this coefficient, I will write a. Okay, and we will start from the b raised to the power 0, and the highest power I will give to 4. And see, it is not a requirement that you will always start with you will always give the zeroth power to b. Okay, you can do it alternatively also. You can also start. Okay, so you can also write it like this: a raised to the power 0, b raised to the power 4. Okay, because you can see that all these coefficients are symmetric. Can you see the symmetry here? 3 3 is symmetry, then 1 1, and 6 is in the center, and 4 4. Okay, so it is symmetric in nature, so it doesn't matter which particular variable you give highest power and decrease it, and the other one to increase it. Okay, so it is 1 b raised to the power 0 a raised to the power 4. Then I will pick this coefficient right here, 4. It will be 4. Now I will increase the power of b by 1. It will become b raised to the power 1. And now I need to reduce the power of a by 1, so it will become a cube. Similarly, now I will pick this coefficient here, 6. It will become b square because I am increasing the power of b, and I am decreasing the power of a. Similarly, 4 will come here. It will be b cube and a, so because I am reducing the power of a. Now the last coefficient is 1. B will get the highest power 4 and a will get the power 0. So if you simplify it, okay, let me erase this. So if you will simplify it and write it neatly, it will become a power 4 because we will just do 1 here. It will become 4. So a better way to write it like this: 4a cube b plus 6a square b square plus 4ab cube plus b raised to the power 4. Okay. Okay. So this will be the our identity for. So this is our identity for a plus b whole raised to the power 4. Okay. So this is how you can actually use the Pascal's triangle in order to find the powers, the expansion of any particular binomial term that is given in your paper. And there are lots of exercise given in your text. They are pretty simple exercise. You can try those exercise, and you need to be a little bit careful when you have, for example, a minus sign. For example, if I'm picking one question from your textbook, it is asking that you need to give the expansion of x minus y raised to the power 4. Okay, so the same identity, I'm just showing you how you can actually use the same identity here. So here the value of a is nothing but x, and the value of b is, need to be careful that the value of b is nothing but minus 1. Okay, so if you substitute it, it will become x power 4 plus 4 a cube And in place of b, write in brackets minus 5 plus 6a square b square is nothing but minus 5 the whole square plus 4a in place of b cube I will write minus 5 the whole cube. Then the last term is b raised to the power 4. Okay, so then if you will simplify this, it will become x power 4 minus this minus sign will come here, it will be 4x cube y. Then this minus sign when it gets squared it will become plus, so it will become 6x square y square. Now here when you calculate the cube of a negative term, it will give minus sign outside, it will become 4xy cube, and this will become plus y raised to the power. Okay, so this was actually one question from your textbook. It was 1E. Okay, so 1E from exercise 6A. Okay. You can solve other questions also. I'm encouraging you to try to solve as many questions from this exercise. So, but use this fastest triangle, okay? And you need to make it, for example, till power 6 or maybe power 7. But the idea is pretty much simple. You just start like this one, then write 1 1, then 1 2 1, then sum it 1 3 3 1, then 1 4 6 4 1, then it will be 1 5 10 10 5 1. So it is for power 0, for power 1, for 2, for 3, for 4, for 5. Like this, it will go on. Okay. So just see in that particular question which power they have asked and just make this Pascal triangle till that power and just note down the coefficient and then apply the same method. Okay. Pick one variable and increase its power and then for example first variable increase its power and for second variable you need to just decrease its power. Okay, and we will get the correct answer. So I hope you understood this particular session and hope to see you soon. Thank you very much.